What would happen if you shot a gun in space? Let's play this out to its logical conclusion. Welcome to the channel. In October of 1998, American astronaut Jerry Linenger fired his gun in space while on a Russian space station called Mir. He did so to test what would happen, and the answer is nothing. You can't actually fire a gun in space. There's no air for the bullet to travel through. The only reason guns work on Earth is because we have an atmosphere that compresses as the bullet passes through it. That compression propels the bullet forward. Without that atmospheric pressure, the bullet won't move at all. But what if there was a way to shoot a gun in space? How would that change everything? First off, we'd need to get people into space. To do that, we'd need to make spaceflight cheaper. To make spaceflight cheaper, we'd need to make rocket fuel cheaper. But rocket fuel is just refined petroleum, so we'd need to make oil cheaper. We can do that by making OPEC irrelevant. The easiest way to do that would be to discover a new oil field, one so large that it dwarfs all other reserves. I'm talking about an oil field so big it makes Saudi Arabia look like a garage pump. We haven't found such an oil field yet, but we will eventually. And when we do, the owners of that field will become so rich, they'll fund their own space programs. And one of those programs will figure out how to shoot a gun in space. But then what? Well, let's start with social and cultural changes. If you've ever watched Star Trek or Firefly, you know that guns are probably not going to be that useful in space. In Firefly, the crew of the Serenity almost always had to resort to using shotguns loaded with lots and lots of rocks to take down enemies. In Star Trek, phasers were basically the universal weapon of choice because they could stun or kill at a distance without any physical harm to the victim. This seems much more efficient than guns. And given that we already have highly advanced rifles that can stun or paralyze targets, it's likely that this technology would simply replace guns rather than being used alongside them. Politically, the discovery of a massive new oil reserve will lead to a massive transfer of wealth and power. Countries with large reserves of oil, particularly OPEC nations, will become significantly richer and more influential. They'll use this newfound wealth to build up their militaries, both in terms of conventional weapons and also in terms of spaceflight capabilities. This will lead to a new arms race, this time in low Earth orbit. It's here that gun-wielding astronauts will battle it out in space stations and on the surface of the moon. The global economy will continue to grow rapidly as the price of oil falls and transportation costs decline. After all, with the threat of interplanetary war looming, countries will want to make sure that they can quickly and easily transport resources and troops around the solar system. The result will be a period of intense economic growth, especially for countries with access to the new oil fields. On a day-to-day basis, life on Earth will go on as normal, at least for a while. People will travel to and from space as regularly as they currently travel between countries. And some very lucky individuals will get the chance to live and work in space stations, mining asteroids and battling hostile aliens. But not everyone will be so lucky. For every resource extracted from an asteroid, there's an equal and opposite reaction. Space junk will become a serious problem as thousands of tons of equipment, weapons, and human waste are left behind in low Earth orbit. The Earth's surface will become increasingly polluted, as well as entire layers of the atmosphere are removed in order to make rocket fuel. At this point, the world will begin to resemble the dystopias depicted in films like Children of Men or The Road. There will be rebel groups fighting against the oppressive regimes that control access to resources. And these rebel groups will be led by individuals who possess the ability to operate guns in space. Now, you might think that shooting a gun in space is pretty easy. All you need is a bullet and a gun. But the truth is, there's a lot more that goes into it than that. The gun needs to be able to seal itself after firing, and it needs to be able to expel gas from the chamber without damaging the delicate equipment inside the space station. Additionally, the astronaut needs to wear a special suit that allows them to breathe and see while still being able to operate the gun. Oh, and they also need to make sure that the bullet doesn't hit anyone else. This is a tricky task, since the bullet will continue to fly forward indefinitely. Luckily, space is mostly empty, so there isn't much to hit. But if the astronaut misses, the bullet will continue flying until it eventually hits something. This could be another astronaut, a piece of equipment, or even the hull of the space station itself. If the space station is damaged, the air inside will begin to leak out, which could cause the death of everyone on board. To prevent this from happening, space stations will need to be built with multiple layers of protection, each designed to stop bullets of different sizes and speeds. But what if someone breaks through all those defenses? What if someone fires a gun at the heart of a space station? Well, the answer depends on where the bullet goes. If the bullet hits the core of the station, it'll travel through several kilometers of metal before coming to a stop. Along the way, it'll rip apart electrical cables, plumbing, and life support systems. But unless it hits a critical component, the station should still be able to function. If the bullet instead hits the outer shell, it'll be met with a vacuum and will slow down rapidly due to atmospheric drag. Eventually, it'll come to a stop and float away into the darkness of space. But what if the bullet doesn't stop? What if it keeps on going forever? Well, in that case, it'll eventually reach the edge of the solar system, and then it'll enter interstellar space. Here, it'll continue to travel until it eventually hits a star, a planet, or perhaps even a black hole. Of course, there's another possibility. The bullet could simply disappear. As the universe expands, the space between galaxies is growing larger and larger. Eventually, the bullet will find itself so far away from everything that it'll no longer be able to detect. In fact, we won't be able to detect anything beyond a certain distance. Because light takes time to travel and the universe is expanding faster than light. In other words, the bullet will disappear from our universe entirely. But wait, there's still one more possibility. The bullet could travel back in time. That's right, if the bullet were to pass through a wormhole, it could end up anywhere in the universe at any point in history. This means that the same bullet could theoretically be fired at the Big Bang itself. Or it could be fired into the sun, or into a black hole. In fact, it could even be fired into a time machine. Speaking of which, that raises a fascinating question. What if a bullet were to be fired into a time machine? Would it create a paradox? Would the bullet destroy the time machine? Or would it simply disappear? We may never know the answers to these questions, because we've never been able to fire a gun in space. But now that we have, we should keep our eyes open for bullets traveling backwards through time. Now check out what would happen if you jumped straight up really high, or click this other video instead. But do it quickly because you only have 24 hours.